Hello, welcome on board. Today's topic is Cloud Native Trusted Container Registry for Kubernetes. I'm Suraj Yadav, working as a business strategist, joined by my colleague Vijay Mechri, who is a solutions architect, and we both are from the SUSE India GSO team. Let me briefly touch the agenda points. We'll be discussing container registry, their types, what is the need of private registry, some of the open source private registries, Harbor architecture, followed by demonstrating Harbor's integration with Rancher. So let us see what is container registry. So a container registry is a collection of repositories for storing container images. Container images include system libraries, system tools, and other platform settings that makes up an application, giving developers the required benefit of agility and portability to quickly expand or create new applications. A container registry essentially acts as a place to store container images and share them via a process of publishing to the registry and pulling into another system like a Kubernetes cluster. Registries are broadly classified into two types, public and private. So, public registries are commonly used by individual or small teams that want to get up and running their registries as quickly as possible. However, it can bring more complex security issues like patching, privacy, and access control. Private registry provides a way to incorporate security and privacy into enterprise container image storage, either hosted remotely or on premises. These private registry often come with advanced security features and technical supports. Docker Hub is a quick and easy starting point for those who are new to the container registry. It provides access to more than 100,000 off the shelf images shared by software vendors, open source projects, and Docker community of the users. Self hosted registries are the more advanced solution for organizations that prefer to host their container images on their on premises and cloud infrastructure, typically because of security compliance or low latency requirements. Third party registry services are fully managed offering and without the operational overhead of self hosted registries. Third party registry services are like Amazon ECR, Azure Container, Google Container Registry, so on and so forth. Yeah. So we have seen that the different types of private registry, we have seen a basic difference in that one. So let us more elaborate on why private registry is needed at first place. So private registry provide enterprise grade security and privacy whether we are using self-hosted or third-party services. Some of the benefits of the private registries are like access control, which prevent unauthorized user uploads and manage actions based on their roles. Access to private registry can be integrated with the wide variety of identity providers. Enhanced security and configuration capability like digital signing, vulnerability scanning, user activity tracking, and auditing are another set of benefits. Large images may create performance due to latency when accessed over the internet. Instead, images can be pulled from a private repository within confined latency. Private registry can be hosted across platforms from on-prem to cloud, and even third-party services are readily offered by hyperscalers on their public cloud. Let us see some of the open source CNCF private registries. So Harbor, Dragonfly, Portus, and Quay are open source private registries listed on CNCF. Harbor is CNCF graduated, and Dragonfly is still in incubating state. We have provided a link to see the full list of CNCF container registries here. So Harbor is an open source trusted cloud native registry that store, sign, and scan contents. Here are the essential features available in Harbor. With respect to the security, images scanning to identify compromised and unpatched vulnerabilities, digital signing, image authentication, and other tamper protection features. Beyond that, for the management, they have the extensible API and web UI. They have the strict governance such as role based access control and compliance monitoring. So these are the features which makes our choice easy to have Harbor as an integration demonstration. This is a high level architecture of Harbor. We are highlighting some of the key components like core services, which is responsible for user interface, APIs, and integrating with the identity provider. It also controls registry version 2, vulnerability scanning, log collector, persistent database, and admin services. Now let us see the demo in the action. So we have planned two demonstration. One is based on the on-premises setup, and another will be on the cloud. So my colleague Vijay will take you for the on-premises setup. Yeah, Vijay, it is yours. Thank you.
Thank you, Suraj. In this demo, I will showcase Harbor integration with Rancher. Demo is designed to cover the following topics. Quick overview of Rancher, Longhorn, and Harbor UI. Sample container image upload into Harbor instance and scanning the images for any security vulnerabilities. Harbor integration with Rancher, application deployment by pulling images from Harbor. I will be using the on-prem version of the demo setup, and Suraj will be demonstrating Harbor integration with Rancher using cloud setup. This is a high-level overview of my on-prem lab setup, which consists of a Rancher management server deployed on a single node RKE cluster, Harbor deployed on a four-node Kubernetes cluster with Longhorn as a um, persistent storage and Metal LB for uh, load balancing. There is also a downstream cluster which is built using a single node RKE cluster, and we will be using this downstream cluster for deploying sample applications. Let me switch over to the demo setup, and I will be quickly run through the various dashboards which I will be using during my demo. And the one which you are seeing is the Rancher management server homepage. Let me navigate to the cluster management page. This will show you the list of clusters which are currently configured within Rancher. As you can see, there is two clusters which are configured, local cluster and RKE cluster 1. Local cluster is the one which gets deployed when you install Rancher for the first time. And RKE cluster 1 is the downstream cluster which has been imported onto this cluster. And we will be using this particular cluster for deploying sample applications. Switching to Longhorn dashboard, which is used for storing the images persistently. And as you can see, there are six volumes which are configured. Storage volumes are configured currently, and if you want to see the details of each of these volumes, by clicking on this volume tab, you can notice that the status of each of these volumes and their volume binding to various pods associated to Harbor. Switching to Harbor dashboard, uh, as you can see, there are currently two projects which are configured. Library is the one which gets deployed by default when you install Harbor for the first time. And SUSECon is the project which I have created. Let us check what all repositories are currently configured in SUSECon project. So as you can see, there is a Nginx repository which has one image currently residing on this particular uh, repository, which is named as Nginx. Okay. So now let us upload some sample images onto this Harbor instance. Okay. So for that, I need to switch over to my terminal screen. Master one is my downstream cluster. Let me list out the uh, the various images locally present in this particular node. So these are the various images which are currently available. So let us pull two new images and upload onto the Harbor instance. Okay. For doing that, I need to leverage a few commands. So I will be downloading two images, which is BusyBox and Rancher demo application. Let me do that. I will pull these images using Docker pull command. Sorry. Now the pull of images is completed. Let me tag these images by using docker tag command, and once this now we need to upload these images onto Harbor instance. So for doing that, I need to first connect to the Harbor instance using docker login command. Login is succeeded. Now let me push these two images onto Harbor instance. So I'll be using docker push command. So let us verify whether these images are successfully uploaded into Harbor. So for that, I will switch to Harbor instance dashboard. Let me go back to SUSE project. As you can see there, earlier there was only one Nginx repository. Now the two repositories have been created, um, which confirms that the images have been uploaded successfully. So now let us perform a scan operation on this particular image. Okay. So for doing that, it is very simple. Select this particular image and click on scan, and the scan will get initiated. Within few seconds we can see that whether this image is free from any security threats. So as it reports that there is no vulnerabilities found on this image. So now let me switch to the Rancher instance for deploying an sample applications. Okay. So for that, I will connect to this RKE cluster one using explore button. So before I deploy an application, we need to ensure that the required credentials for accessing Harbor are defined. So for that, you need to click on this storage drop down, click on this secrets. So which I have already created a secret which of type registry. So let me show you quickly. So what all the information are required. So this is the IP address of my Harbor instance, and these are the login credentials of my Harbor instance. Okay. So now let me go back to the workload deployment. Let me deploy a simple application, which is a Nginx application. I will name this application as deployment as SUSE Nginx demo. So I need to specify the container image location. For that, I will switch to Harbor instance. I will come back to this Nginx image. I will choose I will copy this pull command, and I will paste over here. Since I'm using the IP based address for my accessing Harbor instance, so I need to specify the IP address of my Harbor instance. Okay. So let me add the port for accessing this application Nginx. I will choose node port, and I will specify the container port as 80. Uh, and one important thing is that to access this image which is residing in Harbor Private Registry, I need to select the secret key which I have defined earlier, right? SUSE Harbor demo key. So I rest all the details. I will keep it as default. Let me hit create. So it will start deploying this application. So let us check whether this application is successfully deployed by accessing the image from Harbor registry. So as you can see, this application is active. Okay. So now let me also show you how to deploy. An app. How to deploy an application using a Rancher continuous deployment fleet operation. So for that, I need to switch to continuous delivery option. So before this, I need to have my source code available in some source code repository. So for this, I will be leveraging my GitHub repository. uh, so this is an repository where my source code is residing. So as you can see, I have these various deployment YAML files. So this is the deployment file which I want to deploy. So here also I have specified the image location as my Harbor private registry, and I have also specified the image pull secret, which is SUSE Harbor demo key. So let us try to deploy this application, which is residing in my GitHub repository. For this, I need to copy the GitHub source location, and I need to define the git repo location by add repository. So I'll specify this name as susacon uh, fleet demo. I'll specify the URL, and I will select this branch as main branch, and I need to add the path where my source code is residing. So it is live hello world. Okay. So I also defined my downstream cluster with some labels. Okay. So I want to deploy this onto this cluster group, which is SUSE Fleet demo. Okay. And I will hit create. So as you can see, this application has been successfully deployed, which is which is getting deployed. So let us wait. Yeah, it has been deployed successfully. Now all three uh, resources has been deployed successfully. Let us try to access this application by navigating to this particular cluster. Okay, so I need to go back to the cluster explorer. I'll go to service discovery. So there is a hello world is the application, right? So there is the Rancher demo application which has been successfully deployed by accessing the image residing in the Harbor registry. So now let me change the source code a bit, so that we will see whether this has been can be integrated successfully or not. Okay, so let me change the value in my source code from blue to green. I'll commit these changes in my git repository, and let's see whether this hello world program will those changes will take effect. Okay. So so the fleet controller will notice that there is a change in the source code. So for that, let me go back to the continuous delivery option. So as you can see, the fleet controller has recognized that change, and it is already terminating the previous pods and recreated the new pods. So let us check the application itself. Right. So as you can notice here, so the blue pods has been changed to the green pods, and over the period of time, the blue pods will be terminated altogether. Okay. So with this, I complete my demo. And I would like to hand it over back to Suraj for the Harbor demo on cloud setup. Thank you.
Thank you, Vijay, for the wonderful demonstration. Let me take you to the cloud. So this is a high-level overview of AWS Cloud Lab setup, which consists of the Rancher management server, which is built on RKE2 cluster, Harbor deployed on a single node Kubernetes cluster, having Longhorn as a persistent storage, downstream single node RKE2 cluster for application deployment, and some additional cluster, for example, the EKS for application deployment. So let me take you to the Rancher and the existing setup there. Yeah. So this is the home screen of the Rancher. Let me quickly take you to the respective clusters. Here we have application running on a single node RK Harbor application running on a single node RK cluster, which is here, and it is having Longhorn as a persistent storage. Let us see what's the volume status. So all those six volumes are healthy, up and running, everything good for go. So let me quickly take you to the Harbor setup, what Harbor setup is currently there. So within the projects, we have a couple of libraries created. One is by default, two libraries are there, which I have created. One is public and another one is the private. I have pushed Nginx image over here. Let me show you the setup for this one. So initially, did the Docker login, then pull the Nginx image here. We have then tagged the this. We have tagged the images there with the respective Harbor registry, and then we have pushed the container image to the registry. So that has been successfully pushed here. Now let me show you the rest of the integration setup. So for this one, we will quickly go here on the cluster under the storage, secrets, and we have the Harbor registry URL and the user ID credentials, which will be required to deploy an application. So if we quickly go to the workloads, create a workload here. So simple deployment. So, demo next application that will pull out the path here. So, let's do this one. Yes. Secret Harbor, add the node port running on PT. Simple, create the deployment. Let us see the deployment is ready. It is deployed. Let's go to the services and look at the service. So this is a pretty straightforward setup. So which concludes the demonstration. And if I summarize everything, we have discussed about the container registry, types of container registry. We have seen the need of the private registry, how private registry is helping enterprises to create a secure repository. And for that matter, we have chosen Harbor, which is CNCF graduated project. We have shown the demonstration for both on-premises as well as the cloud setup. We have shown the applications running on the Rancher cluster which is managed by Rancher. And that concludes the today's agenda. I hope you had liked this session. For any queries, please feel free to reach out to me and Vijay. Our email addresses are provided in the slides. Thank you very much.